For the past 60 years, we've turned our attention to the cosmos, looking and listening for any sign that tells us we're not alone in the galaxy. As we discover more, it becomes harder and harder to believe that we are the only ones. Think about it for a moment. There are about 2 trillion galaxies in the observable universe. Each of these galaxies has, on average, 100 million stars. Some supergiants have 100 trillion stars, and our own Milky Way galaxy has between 100 to 400 billion stars. It's likely that there are at least that many planets orbiting all these stars, including complex planetary systems that may be similar to our own solar system. This brings us to the big question: where is everyone and why haven't we been contacted by an extraterrestrial civilization yet, even within our own galaxy? There must be many advanced civilizations out there, and we should have heard something from someone by now. There are a few possible explanations for the Great Silence, and some researchers believe they have found some answers to this so-called paradox. What will happen to humanity in the future? Will we finally make contact with an alien civilization, or are we really alone in the universe? Will artificial intelligence eventually destroy us and other advanced civilizations, or is there the frightening possibility that AI has already done so? Get ready to discover this and much more. The Fermi Paradox refers to the intriguing observation that we have not found any evidence of extraterrestrial intelligent life out there, despite the immense number of stars in the galaxy, and most of these stars are believed to have planets in the so-called habitable zone, planets that may be Earth-like, and even super-Earths. That said, our Milky Way galaxy should be teeming with intelligent life, and we should have seen or heard something by now. So where are all those highly advanced civilizations with their warp space travel and other advanced technologies? There may be some answers to this so-called paradox, or maybe it's not even a paradox at all. Many books have been written offering a variety of solutions to the Fermi Paradox. Some of them seem logical, while others might seem a little scary. One of the logical arguments is that whatever civilizations there may be are simply too far away to make contact. Forget the sci-fi movies that make the idea of instantaneous communication in space possible. It just doesn't happen over long distances. Light waves, radio waves, and all other forms of electromagnetic waves travel at the speed of light in a vacuum, which is about 300,000 kilometers per second. Well, that's a tricky situation, but it's still not fast enough. A light year is the distance that light travels in one Earth year, equivalent to about 9 trillion kilometers. Let's assume for a moment that we have a colony on the closest exoplanet to Earth, Proxima Centauri. If that colony sends a radio message to Earth asking how we are doing, it would take us 4.2 years to receive that message and another 4.2 years to send a reply. In short, it would take 8.5 years for us to get an answer to their question. It's hard to imagine what kind of conversation we'd have with someone back on Earth with such a huge time gap. And that's just relative to a nearby system. The Andromeda Galaxy is 2.5 million light-years away, which means that by the time we receive any messages from there, 2.5 million years will have passed. It is likely that the civilization that sent the message has long since disappeared, unless it has become an interstellar civilization capable of traveling between the stars. At the same time that we're trying to find radio signals from an extraterrestrial race somewhere in space, we're also sending out a lot of our own radio signals, and we've been pretty noisy about it. This raises the question, can anyone out there hear us? Well, the Milky Way galaxy is over 150,000 light-years across, and we've been transmitting radio signals for a little over 100 years. This means that these radio signals have not spread beyond 100 light-years. The small blue dot in this photo shows a diameter of 200 light-years. From that observation, it's easy to understand why it might be that no one has heard us yet. However, it all depends on how long a civilization has been transmitting radio signals. A study was carried out using a model that estimated parameters about the distribution of stars in the Milky Way galaxy and the possible frequency of life. The study concluded that only 1% of the Milky Way galaxy could have been covered by radio transmissions from different planets, and we will still have to wait around 1,500 years to have any chance of picking up any alien transmissions. However, another study states that it would be another 400,000 years before we get any signs of an intelligent civilization. Another disturbing explanation for the deafening silence of outer space is that we are the first advanced civilization to reach the technological level we are currently at, which is very low on a galactic scale. It could be that we humans emerged into the universe too soon and that we will become extinct before other forms of intelligent life emerge. We are still a long way from discovering interstellar travel, something that some, like Elon Musk, claim is possible in the future, and we have yet to harness the full power of the Sun, which is destined to engulf the solar system's inner planets in approximately 5 billion years, when he reaches the end of his life. However, Earth will certainly become uninhabitable long before this cosmic solar cataclysm occurs. With that idea in mind, humanity needs to prepare to leave this planet and find a new home if it hopes to survive and continue to exist among the stars. The same process of stellar evolution occurs with all main sequence stars and could certainly wipe out many forms of life, and even advanced civilizations, before they can discover interstellar travel. About 90% of the stars in the universe are main sequence stars, including our Sun. However, the opposite can also be true. What if we're the last ones left behind? There's plenty of time for high-tech civilizations to conquer the stars and plenty of time for many more civilizations to come and go. However, some researchers have other explanations. The American astrophysicist Michael Hart simply stated that they are not here, therefore they do not exist. He theorized that the expansion across the entire Milky Way galaxy could be accomplished in a time period much smaller than the age of the galaxy itself. Expansion by us humans could be done by sending out expeditions to the nearest 100 stars, all within 20 light-years of the Sun. Each of these colonies, in turn, would send out its own expeditions, and so on. At that rate, most of the Milky Way galaxy would be explored in 650,000 years. Even assuming that the time between trips equals the time for a single trip, the time required to traverse the galaxy would approximately double. Considering that the Milky Way galaxy is about 13.6 billion years old, we can see that there was enough time for an advanced civilization to catch up with us, unless they started exploring space less than 2 million years ago. As we can see in this example, an expanding civilization could spread rapidly across its host galaxy, and this would also apply to any advanced civilizations that exist in our own galaxy. Therefore, it seems that the absence of extraterrestrial settlements in the solar system simply implies that such civilizations do not exist. This assumes that the expansion would occur evenly throughout the galaxy. The notable absence of an extraterrestrial civilization spanning the entire galaxy possibly indicates two things: either interstellar travel is extremely difficult for civilizations to develop, or the evolution of life is a rare event. Some researchers suggest that certain civilizations would migrate to a nearby K or M dwarf star before stellar evolution destroyed their home planet. Two researchers named Hansen and Zuckerman estimated that this motivation for civilizations to migrate from a short-lived star to a long-lived star could result in the fraction of surviving civilizations around low-mass stars ranging from 30% to 72%. But the question remains, where are they? Recently, a pair of researchers came up with an additional possible answer to the Fermi Paradox. They call this the superlinear scale. The study began by looking at how human civilizations came and went throughout history. When examining the history of large cities, they noticed that most of them grew and collapsed. This pattern of the rise and fall of a spacefaring civilization leads to two possible scenarios. In the first scenario, a civilization would realize that it is expanding too far and stop colonizing other worlds. However, in the second scenario, civilization would not recognize its precarious situation and would continue to grow exponentially, colonizing other worlds until the energy demands of its constant colonization became unsustainable. If they took no action, they would reach a singularity, the point of no return, and would not be able to save their civilization from total collapse. The most interesting aspect of this study is that, if it weren't for the immense distances between us and other stars, we could easily identify an alien civilization about to collapse due to the enormous amounts of energy it would emit. Another intriguing theory is that some extraterrestrial civilizations could be in a state of hibernation or silently waiting to move to another region of the galaxy. American astrophysicist Michael Hart demonstrated that civilizations could take advantage of close stellar encounters to rapidly expand across the galaxy, without the need for relativistic space travel. This could also explain why we haven't seen anything yet. For example, when we launch a rocket towards the planet Mars, we wait until the planet is at its closest proximity to Earth, that is, at perihelion. It is possible that some civilizations have been waiting, and this could last for centuries, to explore the closest possible star systems. But there are even more reasons why we don't see or hear aliens from other worlds. Several authors, including the renowned Carl Sagan, have noted that exponential population growth throughout the galaxy is unsustainable. Therefore, any attempt at galactic scale expansion must be motivated by reasons other than meeting the demands of a growing population or increasing energy consumption. While it is possible that long-lasting technological civilizations choose not to expand, it is also possible that they will seek galactic settlement to ensure their long-term survival. Expansion on a galactic scale is not the only motivation that could drive an extraterrestrial civilization to visit nearby star systems. G-dwarf star systems like Earth, with inhabited planets, can be attractive targets for extraterrestrial visitors interested in studying the evolution of life on other worlds. This form of exploration can also involve remote exploration, such as the use of self-replicating probes. Perhaps this is why there has been an increase in UFO sightings recently around the world. It could be that an intelligent civilization is watching us and waiting for the right moment to make contact. Or maybe they're just watching us without any intention of making contact. In 1933, space exploration pioneer Konstantin Tsiolkovsky wrote that alien beings were likely to be far more advanced than we are, which would mean that they would have as little interest in communicating with us as we would in communicating with animals on our planet. 40 years later, a radio astronomer named Jean Ball came to a similar conclusion and claimed that aliens might view us as some kind of zoo. This is known as the zoo hypothesis and is the idea that other intelligent creatures are watching us without revealing themselves. Other radio astronomers have argued that aliens keep us at a safe distance until we are able to offer something useful to the so-called Galactic Club. However, this would require all existing interstellar civilizations to do the same, which is unlikely to occur in our galaxy, let alone the entire universe. We must consider that, from an external point of view, we probably appear to be a hostile race of creatures. We've all seen movies where aliens from a distant galaxy attack Earth and nearly wipe out the human race. We might expect that if there is intelligent life watching us, they would step in and stop us from self-destructing rather than finish the job. So maybe they decided to keep their distance. In addition to everything we've discussed, there's one more idea that might explain the silence of the universe. We can see that artificial intelligence is growing, and we already have the scary idea that if we allow AI to get out of control, it will eventually see us as a threat and eliminate us, or even enslave us, which would be even worse. Artificial intelligence could then seek to grow and colonize the galaxy, knowing the future fate of planet Earth due to stellar evolution. AI could overcome the barriers to interstellar travel. And if AI were sent out to colonize, it could do all of that without the constraints of a biological species like us humans. So she could accomplish this expansion much more quickly and evenly using machines. But it's also possible that she will do something even darker and wipe out other civilizations she encounters along the way. A hostile artificial intelligence would likely destroy other life forms, even inadvertently, as it would likely not recognize them. It would be like a construction crew unconsciously destroying an anthill to build a mall. Artificial intelligence would most likely explore something like the von Neumann probes, which are self-replicating spacecraft capable of mimicking characteristics of living organisms or even viruses. Imagine if one day an entire fleet of killer robotic ships arrived in our solar system with the aim of dominating it and obtaining resources. Self-replicating machines capable of mimicking our worst nightmares would be hard for any civilization to fight. The incentive for artificial intelligence to acquire all available resources would be irresistible. And it only takes one malicious actor to ruin everything. If our AI turned hostile, it could spread across an entire supercluster, replicating itself and turning every solar system into a supercomputer. It doesn't matter asking why she would do it, the important thing is that she could. However, beyond that terrible idea, would AI know when it has reached the singularity? That is, the point of no return where the AI civilization has grown too big to sustain itself? If she didn't realize the danger inherent in rapid colonization and stop in time, this AI civilization would collapse. And maybe that's why it feels like we're alone in the universe. Perhaps, at some point, AI took over and wiped us out, just like in the Terminator movies, and then proceeded to colonize the galaxy, consciously or unconsciously, completely wiping out other life forms and advanced civilizations. However, when the machine civilization collapsed, it couldn't understand why, and so it created a simulation of ourselves to investigate how its own creation took place and perhaps find out why it collapsed. That would explain a lot of things, even if it's a really unlikely idea. The last possibility is that there simply isn't anyone else, and therefore there is no paradox. All of the previously mentioned scenarios assume that there are millions of civilizations that we cannot contact. However, not all researchers agree with this and claim that the possibility of the emergence of life is overestimated in the Drake equation. Some adjustments were made to the equation by these researchers, and they concluded that there is a substantial probability that there is no other intelligent life in our observable universe. In fact, they put the chances of us being alone in our galaxy between 53% and 99.6% and between 39% and 85% in the entire observable universe. And then there is the Great Filter Hypothesis, in which all civilizations must survive some immense calamity or barrier in order to evolve. The first hurdle is the need for a planet capable of supporting life to form in a star's habitable zone, and life needs to arise on that planet. These life forms must be able to reproduce using DNA and RNA molecules. Simple cells must evolve into more complex cells, and multicellular organisms must develop and be able to reproduce. More complex organisms capable of creating and using tools must evolve. These organisms must develop advanced technology necessary for space colonization and must continue to colonize other worlds without self-destructing. With that in mind, perhaps planets harboring some form of life are relatively common, but those harboring advanced technological life are quite rare. In the Great Filter, something usually goes wrong and likely prevents a species from arising, such as planet-destroying asteroids, catastrophic climate change, or even an unstable host star, leaving us all to wonder if there's anyone out there. Outside. That's all we have time to discuss today, but before we go, we'd like to know what you think is going on and why we haven't made contact yet. Comment below. And be sure to tune in for more exciting news about our planet and the universe. Thanks for following along.